Hello students, welcome to my lecture. In this video, I will discuss a question from the modern physics topic and especially from nuclear physics and radioactivity based. The question as follows. Nuclei A is having a mass number 220 and binding energy per nucleon is 5.6 MeV and split into two fragments B and C of mass numbers 105 and 115. The binding energy of the nucleons B and C is equal, that is 6.4 MeV. Then what is the energy released here? Then A is breaking up into two parts, B and C. A is having a mass number of 220 here and B is having 105 and 115 C is having. Here the binding energy per nucleon is 5.6. Here the binding energy per nucleon is 6.4 and 6.4. Then clearly the problem is what is the Q value of the reaction. We all know that Q value of the reaction is binding energy of the products minus binding energy of the reactants. So Q value will be binding energy of the products. B is formed 105 and that is 115. Again it is 220. Each binding energy is 6.4 minus binding energy, that is 220, into each it is 5.6. So the Q will be is equal to 220 common 6.4 minus 5.6. Okay, it will be 8. That is 220 into 0.8. So Q will be is equal to 22 into 8. That will be is 176 MeV. Okay. The question is a direct question. It's directly based on the Q value of the reaction. So if you remember this technique, binding energy of the products minus binding energy of the reactants will be the Q value. So in what form this Q value will appear? That of course other part. That Q value will appear in the form of kinetic energy of products. Kinetic energy of products. So we can write it will be shared in between kinetic energy of the B and the kinetic energy of the C. So another idea of conservation of linear momentum can be used. So based on that, I can calculate precisely what is the shared amount of kinetic energy of B and kinetic energy of C. I hope it is clear. Thank you for watching my video. Please subscribe my channel and don't forget to like and share.